Hi friends, welcome back to my channel Computer Network. Today we will learn about signals. Okay, now discuss data and signals. Data information can be in the form of data, voice, picture, or messages. To be transmitted, data must be transformed to electromagnetic signals. Okay, data can be defined in signals two categories: analog data and another one digital data. Analog data are continuous and take continuous values. Example such as a sound made by a human voice take on continuous values. Okay, when someone speaks, an analog wave is created in the air. This can be captured by a microphone and converted to an analog signals. Okay, next one, digital data. Digital data have discrete states and take discrete values. For example, data digital data are stored in computer memory in the form of zeros and ones. They can be converted to a digital signal or modulated into an analog signal for transmission across a medium. Okay, example, analog data clock that has hour, comma, minute and seconds and gives information in a continuous. As that is an digital data example, a digital clock that reports the hours and the minutes will change suddenly from 11 o'clock 4 minutes to 11 o'clock 5 minutes. That means the variation 1 minute, 1 2 3. Okay, in analog example, this time, hour, minute, second. In this example, digital data, the the digital data defined to only digital time, that means 11 hour 4 minutes, then increase 11 hour 5 minutes, that means become 4 to 5. Okay, signals in data communication system, a transmitter encodes a message into signal which is carried to a receiver by the communication channel. Signal pass one device to another device, some communication medium. Example, signal pass some cable wire. Okay, in real time example, in our home you have to use light button, switch on off. That means the signal pass. Okay. Signals are classified into two categories. Okay, types of signal. First one analog signal. Second one digital signal. Analog signal. An analog signals is a continuous wave from the changes smoothly over time. As the wave moves from value A to value B, it passes through and includes an infinite number of values along its path. It means an analog signal is a continuous wave. Okay. Next one, digital signal. It can have only a limited number of values. Digital signal is described using binary zeros and ones and therefore cannot take any fraction values. Okay. Digital and analog signals. Analog signals, the curve type, for example, in x-axis values and y-axis time. That means 0 to some 1 second. That means this sine, these waves. Digital signal this type 1 0. That means this square 1 0 1 0 1 0. That means binary numbers. For this picture, analog signal sent from microphone. A person speaking from microphone, the voice read input as a analog signal to convert in digital data. Digital means 1 0 0 and ones format and store in computer system. Analog and digital signals can be two forms. First one, periodic signal. Another one, aperiodic or non-periodic signal. Periodic signal is a periodic signal if complete a pattern within a measurable time frame called period. Okay. Signal is a periodic if the complete pattern within a measurable time frame, that is called frame, called period. That's means the start to curve starting to end. That is mean by these space starting point, ending point are called period. Okay. A period is defined the amount of time required to complete one full cycle. That means it is a cycle one cycle, two cycle, three cycle. Okay. The completion of one full pattern is called cycle. Okay. That means called period one. Starting point ending period one. This curve. Period two. That means period three. T1, T2, T3. Okay. The duration of a period represented by T may be different for each signal, but it is constant for any given periodic signal. Okay. The example of periodic digital signal, digital wave, 0 and 1. That means complete pattern. There is a starting Pattern start, pattern close. That means one pattern is called period, one period, that is called time one. Second pattern, time two. Third pattern, time three. That means period one, period two, period three. Okay. Uh, Now discuss another topic. A periodic signal or non-periodic signal. And periodic signal changes without exhibiting a pattern or cycle that repeat over time. A periodic signal can be decomposed into infinite number of periodic signals. Listen here, infinite of, that means the size is variation, no pattern, no each not starting to ending point. That means infinite of signal passed. Analog signal. Same example, digital signal. Size is variation. 1 0 1 0 1 0 1 0, the space, and next. Okay. It is a very important topic in signals, analog signals. Analog signals can be classified into two categories: simple and composite signals. Simple, this sine wave is the most fundamental form of a periodic analog signal visualized as a simple curve. It is change over the course of a cycle. Is smooth and consistent. A simple periodic analog signal, a sine wave cannot be decomposed into simpler or simple signals. Next one, composite signal. A composite periodic analog signals is composed of multiple sine waves. Okay. Different between simple and composite, it cannot be decomposed. Okay, that means the curve cannot be decomposed. Example, this sine wave size is same size, curve up down, same size. But composite signal composed of multiple sine waves. You have to multiple sine waves. Okay, multiple sine wave. One sine wave, one, two, three. Okay. Okay. Sine wave. The sine wave is most fundamental form of a periodic and analog signals. Sine wave can be described by three characteristics. This is a very important topic in analog signals. First one, amplitude, period, or frequency, phase. Okay. First one, amplitude. What is mean by amplitude? Listen here. In audio, video, you have to increase a value, sound increase. That means that is called amplitude. The amplitude of a signal is the value of signal at any point on the wave. It is equal to the vertical distance from given point on the wave from the horizontal axis. The maximum amplitude of sine wave is equal to the highest value it reaches on the vertical axis. Amplitude is measured in either volts, amperes, or watts. Amplitude, listen here. The curve start and up and down period of one. That means the peak amplitude means this value is calculated the starting the center point of highest point, that is called signal with highest peak amplitude. Another one, that means peak value is low peak amplitude. It's an amplitude that is called plus or minus. Next one, frequency. Frequency is a number of cycle or periods in 1 second. Frequency is the relationship of signal to time. Frequency is the measure of the rate of changes. The rate at which is a sine wave moves from its lowest to highest level is frequency. Okay, the rate of change of signal with respect to time. The unit of frequency is hertz. Okay, listen here. This picture. Frequency number of cycle period in 1 second. For example, we have to take 0 to 1 second. Okay, 0 to 1 second timing. Time amplitude, you have to a cycle first, that means called period or cycle. Okay, first cycle you are starting 1 second cycle, 2 cycle, 3 cycle, 4 or period cycle, 5 cycle, 6 in 6 period or cycle in 1 second, that is called frequency. That means 1, 2, 3, 4, 5, 6. That means 6 hertz. Okay, are you understand this example? This is a very simple example. Okay, type of frequency in 0 to 1 second. That means 1, 2. That means low frequency mean in 1 second the signal pass only two curve, 1 and 2. That is low frequency. Second one, medium frequency. That means 1 second, 0 to 1. That means curve 1, period 2, period 3. That means 3 periods. Okay. Third one, high frequency. The signal passes highly. That means you have to count 1, 1, 2, 3, 4, 5, 6. Okay. That means a signal repeatedly passes in high frequency. Okay. Okay. Period. Period refer to a amount of time in seconds. Yes, signal needs to complete one cycle. Period. That means one cycle amplitude, starting point to ending point. That is called period. Okay. Period and frequency are inverse of each other. Time equal to 1 by frequency, or frequency equal to 1 by time. Okay. Frequency and period. Okay. A signal with frequency in 12, that means 12 period pass 0 to 1 second. That means signals passed. You have count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That means 12 periods in 1 second is called frequencies. 12 units is 12, 12 hertz. Units of frequency and period. Unit, equal value. Okay, seconds, 1 second, that means called 1 hertz. Millisecond, 10 power of minus 3, it is unit referred to kilohertz, microsecond, 10 power of minus 6 second, megahertz, okay, nanosecond, 10 power of minus 9 second, gigahertz, picosecond, 10 power of minus 12 second, terahertz, okay. Phase. Phase describe the position of the waveform relative to time zero. Sometime that can be shifted backward or forward along the time axis. It actually indicates the status of the first cycle. Phase is measured in degree or radian. Okay. Means 0 degree means this is empty. Left hand side empty. That is called 0 degree. 90 degree. That's a curve 50. That means 50 parts inside or 50 parts outside. That is called 90 degree. Third one, 180 degree. Okay, this is called 180 degree phase. Okay, phase one, phase two, phase three, 0 degree phase, 90 degree phase, 180 degree phase. Okay. Next one, composite signals. Composite signal, a signal frequency sine wave is not useful in data communication. We need to send composite signal, a signal made of many simple sine waves. Composite signal, a signal composed of more one more than one sine wave. According to Fourier analysis, any composite signal is combination of simple sine waves with different frequencies, amplitude, and phases. If the composite signal is periodic, the decomposing gives series of signal the discrete frequencies. If the composite of signal is non-periodic, the decomposition gives the combination of sine wave with continuous frequency. Okay, generally the sine waves, the signal is decomposes multiple sine waves. Decomposition of composite periodical signals in the time and frequency. Okay, the generally the wave, simple wave of decompose multiple sine wave, 1, 2, 3. Okay, frequency, that means frequency 1, 2, 3, three frequency. That means another. You have to count this blue line: 1, 2, 3, 4, 5, 6, 7, 8, 9 frequency. Okay, the multiple sine waves, multiple waves to pass 0 to 1 millisecond. Okay, that is called decomposition. Okay, time and frequency of domain. First one, a signal with frequency 0. Frequency 0 means how to become 0. That means in 1 millisecond, 1 second, sorry, 0 to 1 second, no waves format in no signal passed in this direction. It's called frequency 0. No data available, no signal available in this picture. Second one, 0 to 1, a signal with frequency. That means you have to 8 waves, analog waves go to. You have to count 1, 2, 3, 4, 5, 6, 7, 8. That means frequency 8. Next example, 16 frequency in 1 second. Okay. Okay. Thank you.